Bismillahirrahmanirrahim. Exercise 1k of chapter 1. In this exercise, our main goal will be how can we change scientific notation or the standard form into ordinary form, and the opposite, like how can we change the ordinary form into standard form. So let's quickly discuss what is standard form and what is ordinary form of a number. For example, when you write the numbers like let's say we have this number. So it's a very large number, and this is the normal way to write a number. So such form is called the ordinary form. What is this called? This is called the ordinary form to write a number. But if you write a number with the powers of 10, for example, if you write 4.2 times 10 to the power, let's say 7. Now actually this one is also a very large number, but it has been written in a shorter way. So scientific notation, or you can say the standard form, is a short way to write very large numbers or very small numbers. Actually, scientists and the mathematicians, sometimes they have to deal with very long distances, very small sizes of the, let's say, atoms or cells. In that case, they deal with very small numbers, right? So the short way to write very large or very small numbers is called the scientific notation or the standard form. It looks like this. Okay, if you notice that the first part of this scientific notation, like this one, this part, it is a number between 1 and 10. It will always be a number between 1 and 10. And this part of this scientific notation that is having the powers of 10, if it will be a very large number, the powers of 10 will be positive, and if it will be a very small number, the powers of 10 are going to be negative. Okay, so and it tells us like where the decimal has been, you can say moved or placed, right? Let me explain you with the help of examples now. For example, if you look at this one, my question is write in ordinary form, right? They want me to write this one in the ordinary form. Okay, how can I write it in the ordinary form? So to write it into the ordinary form, I have to remove these powers of 10. Now actually, if you notice that this 3.78 times 10 to the power 6 means we will be having 6 zeros over here, right? Now these 6 zeros says we have to move this decimal 6 places to the right. So when you move this decimal 6 places to the right, let me show you. Right now I have only 2 places, right? So I need to put how many extra zeros over here? 1, 2, 3, 4 extra zeros to make this one 6 places, right? So what the answer will become? This shows that whenever you have this exponent as positive and you want to change it into the ordinary form, what will you do? You will move the decimal to the right side according to the number of powers of 10. If the power will be 5, you will move it 5 places to the right. If the power will be 3, you will move it 3 places to the right. Right now we have 6. The power is 6. That means this decimal is going to move to the right side 6 places, and finally it will reach over here. So our answer will become 378. With that one we will be having 4 zeros. So this will be our final answer. So if you want to check it here from, so this will be your final answer. Clear? What if we have like if we want to change a very large number from ordinary form to scientific notation, right? This number right now it's written in the ordinary form. This one is in ordinary form. Let's say I want to change it into scientific notation, or you can say I want to change it into standard form. So how can I change it into standard form? So as you know that where is the decimal right now? I cannot find the decimal in this number, but whenever there is no decimal, actually it's here in the end, right? And I have to bring it where? Somewhere where the number will be between 1 and 10. So if I will, let's say if I will bring it over here, then the number will be 364. That will not be between 1 and 10. And let's say if you bring it over here, let's say if you bring it over here, still it's 36 on the left side. So I want a number that should be a whole number, like before the decimal, whole number part should be between 1 and 10. So this decimal has to move from this place to this place, right? So my first part of the scientific notation will become 3.647, and as you know that these zeros that comes in the end of the decimal part, we can ignore those zeros, so we will ignore all these zeros, times 10 to the power what? Now see how many places the decimal was moved from here to here. So 2, 3, 4, 5, 6, 7, 8, 9. So it has been moved 9 places, and it's a very large number. So whenever the number is large, that's why the exponent of the 10 is going to be positive. So this will be your scientific notation or standard form from this ordinary form. Clear? Let's solve some more questions now, and better I want you to solve those on your own. Okay, again this is another example, like how will you, where the decimal has to be moved. They want me to change this into scientific notation, or you can say the standard form. So how can we change it into standard form? Where this decimal has to go. Remember, usually we can say the decimal has to go after first non-zero digit. Look at this, all these are zeros, so this is my first non-zero digit. This one is the first non-zero digit. That means the decimal has to go after the first non-zero digit. Clear? Or you can say between the first and the second non-zero digits. So this one will become 1.73. So I got the first part of the standard form. What about the second part of the standard form, in which I have to write the powers of the 10? So the decimal has been moved from here to here 6 places, right? So how I will write the power? Am I going to write it 6? We write positive 6 when it's a very large number. This number is starting with 0. There is no whole number part. That means it's a very, very small number. That's why I have to keep my exponent as negative. The power of 10 is going to be negative 6. Clear? Let's solve some questions from the exercise now. Here are the questions, and I have taken these questions from page number 16. It says write each of the following into ordinary form. So look at this. This one is negative 3. Negative 3 means like you have to make this number very small. How can you make it very small? You have to move the decimal. Remember, when the exponent is negative, the decimal, it moves to the left side. Okay, and when the exponent is positive, the decimal, it moves to the right side to make the numbers larger. So right now it's negative. The decimal has to go 6 places to the left side, and it will reach over here. But these 2 places, I don't have anything over there. So what can I do? I can fill these blank places with the 0. So my final answer will become decimal 0047. And what can you write on the other side, on the whole number side, whole number part of the decimal? Whole number will become 0. Whole number part will be 0 because we don't have any whole number part. Same is the case here. I want you to solve this one on your own. Let me solve this one for you now. It says that exponent of the 10 or the power of the 10 is positive. So that's why the decimal has to move to the right side to make the number larger. So I have to move it 2 places, 1 and 2. So finally it will reach here. So I don't have something over here, it's blank, so I can put a 0 here. So my final answer will become 280, means 280. So these are the 2 answers. Now I want you to solve 8 and 9 on your own, and then play the video to check your answers. So here are the answers, girls. I moved the decimal here 4 places to the left, it reached here, and here I moved the decimal to the right side 6 places. So this is my final answer. Let's solve some more questions. This is question 12 and question 16 from the exercise. Now they want you to change it into standard form, means this is the ordinary form, and they want you to change it into standard form. Do we have decimal here? This is I have to ask my mind 2 questions. Do I have decimal here? There is no decimal, so I can place the decimal here in the end. Second question, where this decimal has to be moved? because I'm changing it into standard form. So that means the decimal has to be placed after the first non-zero digit. So 3 is the first non-zero digit, right? So the decimal will reach here, from here to here. So it has been moved 1, 2, 3 places. So the first part of the the first part of the standard form, it will look like this, times it by 10 to the power what? Now this is the third question that I have to ask my mind, that what will be the power of 10? As you can see, this was a large number, right? It's more than 10. So that's why the powers of 10 are going to be positive. But what will be the number? Now count how many places you moved it. We moved it 1, 2, 3 places. So that's why the exponent of, or the power of 10 is going to be positive 3. And this 0, the 0 that comes after the decimal place by the end, it can be ignored. So this will be your final answer. What about this one? First question, where the decimal has to be moved, where it has to be placed. So it has to be placed after the first non-zero digit. So my first non-zero digit is what? It's 8. So that's why the decimal is going to be moved here, right? And how many places I have moved it? 1, 2, 3, 4 places, right? So 8.5 is the first part of the standard form. What about the second part of the standard form, in which I have to write the powers of 10? Because it's a very small number. It's really small. It starts with 0, right? So that's why the exponents are going to be negative. Negative, what will be the number with the negative? Count 1, 2, 3, 4 places. So you moved it 4 places, so that's why it's going to be negative 4. The main idea is try to understand the situation. If it's a large number, the powers of 10 are going to be positive. If it's a small number, the powers of 10 are going to be negative. How do we know about the number? Only we count the places. We count how many places the decimal has been moved, and that gives us the powers of 10, the number. Okay, here are some questions now. I want you to solve all of these on your own and then play the video to check your answers. So here are all the answers, girls. You can see, if you quickly want to review it, the decimal, there's no decimal, it's here, it has been moved here, so 3 places. That's why the exponent is positive 3. This one is also a large number. The decimal is here, it has been moved here, so 5 places between the movement, so it's positive 5, right? Here it has been moved only 1 place, so that's why it's 3.0710 to the power 1, right? And this can be also written as 3.07 times 10 only, because in my previous video when I was explaining you about the indices, I told you that 10 and 10 to the power 1, or 5 to the power 1, it's same. Okay, now here the decimal has to be it has been moved here, so between its 3 places. Why it's negative? Because it's a very small number. It starts with 0. Okay, now here the decimal will reach here between 8 and 8. That's why 8.8. It's how many places? 1, 2, 3, 4, 5, 6 places. Why negative 6? It's a very small number. That's all for this exercise, girls. It's very easy exercise. Hope you understand it.